Okay, so bottom of page 3, put some frames around each of those sets of radian measures, because those are the trickier ones to kind of learn and memorize, I think. I want to show you some patterns to kind of help the thought process on these, okay?
Sorry about that.
No worries. Notice the purple, that first set, those are our quadrantal angles. And if you notice,
Mute.
our quadrantal angles, that's our 0, 90, 180, 270, 360. If you notice, all of those are either a pi or a pi over 2. So that kind of gives you a hint about those being special, right? If you're seeing something with pi's or if you're seeing something with pi over 2, it's quadrantal, okay? I have these broken up by, if you notice, looking across here, if we go across, those are all of our pi over 6's, so those are our 30-degree reference angles. So the way I have this framed out here is looking by each quadrant. So if you notice, whoops, here's quadrant 1. This next set are angles that are in quadrant 2. The green set that I have here is quadrant 3, and then the last set is quadrant 4. And I'm mentioning that because there's kind of something special about the pattern with the numbers that I want you to notice. 1220.
Okay. I don't want to keep. It's just
Okay, yeah. Thank you.
You're welcome.
Okay. Yeah, thankfully this is working okay, so.
So I have a backup.
Yay, yeah, the beauty of the two screens. Okay, quadrant 1 is just what it is, right? Those are our special reference angles. You're going to get those memorized. Pi over 6, pi over 4, pi over 3, right? And pi is equivalent to 180, so it's pretty easy to do some mental math and figure out what those values are in degrees. Okay, I want you to focus your attention just on these fractions. Look at the fraction part of this. Compare each of those fractions. Compare numerator to denominator in each set, because there's something special that happens in quadrant 2.
They're one less than each other.
Say that again. We'll be a little bit more clear there, Will.
Like the numerator is less than the denominator.
Okay, the numerator is one less than, the number in the numerator is one less than what's in the denominator. Excellent. So if you think about it, in quadrant 2, we're at denominator minus 1 all over the denominator, if you feel like you want or need to make a note about that. And I want you to think about that for a second, guys. It should make sense to you if you think about it. If we rotate all the way around to here, then we're at pi radians, right? Think about all of our common denominators that we would need to have. 6 pi over 6, 4 pi over 4, and 3 pi over 3, right? Okay. So if we are coming up with an angle measure that's in quadrant 2, we're just short of 6 pi over 6, 4 pi over 4, and 3 pi over 3. So it should make sense to you that the numerator has to be a little bit smaller than what the numerator would be here, because we're rotating around to that spot. Right? Think about it in that way. It's got to be smaller than 6 pi over 6, 4 pi over 4, 3 pi over 3. That's for quadrant 2. Think about quadrant 3. We're rotating all the way around. We're going just past what 1 pi would be equal to or equivalent to. So look at these values. What do you notice about the numerator compared to the denominator? Denominator plus 1 all over the denominator. There you go. Okay, and then let's think about quadrant 4, right? We rotate around to quadrant 4. We're just shy of 2 pi. So think about what 2 pi is equivalent to, right? 2 pi could be 12 pi over 6. That's equivalent to 2 pi. 8 pi over 4. And then 6 pi over 3, right? Those are equivalent to 2 pi. But if we're in quadrant 4, then we're just short of that. We haven't gotten quite to that point, so it has to be a little bit less than that. So if you notice, the values in quadrant 4 are 1 less than twice the denominator. So you have to multiply the denominator by 2 and then subtract 1, and it's over that denominator. Okay? Yes.
What is quadrant 1?
Quadrant 1 is just those angles, the pi over 6, the pi over 4, pi over 3. Okay, so even if you don't know, even if it's not a special reference angle that we've been talking about here, you should still be able to figure out what quadrant a radian measure is in, right? As an example, if I give you 8 pi over 7, what quadrant is that in? Say that again? 3. And we know that because numerator is 1 more than denominator, right? If we're at, I don't know, 8 pi over 9, what quadrant is that? It has to be quadrant 2. So we might not know what the degree measure is, but we know it has to be in quadrant 2 because of that fraction. Please keep that in mind. That can be very, 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 very helpful. Okay? All right, onward. Bottom of page 4. I'm going to ask you to write in a couple of things down here. Okay. On the bottom of page 4, if you notice, I'm focusing my attention just on this for right now, okay? And I want you to notice and think about, it's telling us which trig functions are positive and negative in the different quadrants, okay? So if you notice, all of the trig functions are positive in quadrant 1, and that should make sense to you because if you think about it, we're going right, which is positive, and up, which is positive, okay? Whereas in quadrant 2 and in the other quadrants, there's only one trig function that's positive. The other 2 are negative. So notice that in quadrant 2, if you notice, the sine values are going to be positive. Those are our y's. But cosine and tangent will be negative. Quadrant 3, if you notice, tangent is positive. The other 2, the sine and the cosine, are negative. And quadrant 4, cosine is positive. The other 2 are negative. Now, guys, think reciprocals for a minute. If sine is positive somewhere, then so is its reciprocal, which is cosecant. Right? Wherever tangent's positive, that's where cotangent's going to be positive also. That type of thing. So some of you might prefer to kind of look at this and think about it in this format. Others of you may want to learn this little mnemonic device or that little visual where you just put an ASTC that stands for all of the trig functions. S stands for sine being positive in that quadrant. T stands for tangent being positive in that quadrant. And then C stands for cosine being positive in that quadrant. So the saying that we use to remember that, it's a mnemonic device, is all students take calculus, which somehow it seems a little bit ironic the day that I'm talking to you about possibly taking honor statistics instead of calculus, but that's okay. All students take calculus to help you remember that.
It's pre-calculus. Pre-calculus.
There you go. Okay. For those of you who are more of a visual person, I want to share with you another way to kind of think through this. So that's why I'm asking you to draw this here. So we can kind of highlight the 2 quadrants. There's going to be 2 quadrants where each trig function is positive and 2 quadrants where it's negative. So I'm going to highlight where the 2 quadrants where sine is positive. So sine is positive, we know in quadrant 1, and we also know it's in quadrant 2. So guys, think about that for a minute. We know for sine values, we're looking at the y. Think about what I've just highlighted. Those are y values being positive above the x-axis, right? That should make sense. Jace, can you get that? Thank you. For cosine, it's the x's. We want those to be positive. So that would be over here. And tangent's a little bit different or a little bit tricky in that the positive is along the diagonal. More to come about being able to pick out which quadrant we're in and thinking about this, but I think this is a good visual to kind of help with that. For those of you who are more of a visual learner rather than another type of learner. So you just have to remember that the All Students Take Calculus tells us where the trig functions are positive. You do need to keep that in mind. Okay? All right, we need to talk reference angles. So we're going to flip a couple pages. I want you to focus just on quadrant 1. Okay, so this is, remember I told you, we're just going to focus primarily on quadrant 1, and then we'll kind of extend into the other quadrants. So the hand trick helps you with figuring out and determining what the coordinates are at each of those particular degree measures. Okay, so at 0 degrees, 30 degrees, 45. Okay, you have your own God-given unit, quadrant 1 unit circle right here in your left hand. It's amazing. Left hand has to be your left hand. Don't use your right. Left hand. Pinky's going out. Orient your hand, palm facing you so that pinky is basically 0 degrees. Thumb is 90 degrees. Okay? I promise, guys, this is absolutely amazing that this works. And it works for every value here. Okay? If you want to know what the coordinates are at 30 degrees, as an example. So 30 degrees, think about the fact that 30 degrees is your ring finger, right? Ring finger is 30 degrees, middle finger is 45, pointer is 60, and then thumb is 90. So 30 degrees, right? Fold that finger down. That one's the easiest to do. The others I have to like hold my finger. Okay, how many fingers are there to the left that are still up from this folded finger? 3. Guys, what's the x-coordinate here? It's root 3 over 2. How many fingers to the right? 1. How many do you have? What's the x-coordinate over here? So you have to remember that it's square root of that number over 2. You do have to remember that part of it, but that's going to tell you what the coordinates are at each of those points. So square root of 3 over 2, comma, 1/2. Think about 45 degrees. Fold down your middle finger. I can't do that. It doesn't work. How many fingers do you have to the left? 2. So root 2 over 2. And how many do you have to the right? 2. So root 2 over 2. 60 degrees. Fold your pointer down. How many fingers do you have to the left? 1. So your x-coordinate is 1 over 2. How many do you have to the right? Root 3 over 2. So you have to remember the square root over 2 business. It even works for 1 and 0, believe it or not, right? At 0 degrees, fold your pinky down. How many fingers do you have to the left? 4. So square root of 4 over 2, how many do you have to the right? 0. Guys, what's the square root of 4? 2. Over 2, what does that give us when we simplify it? 1 comma 0. Ah, it works even for 0 degrees and 90 degrees. Here's what's going to happen. If you look at that totally blank unit circle there on page 5, and you don't have anything else to look at, the 2 coordinates that are the easiest to get confused are the 30 degrees and the 60 degrees, because you know one of them square root of 3 over 2 and the other one's 1/2, but you never remember which one's which, right? You do now because you have your God-given quadrant 1 unit circle right here. If you can't remember the coordinates at 30 degrees, fold your ring finger down and look. You can write in your square root of 3 over 2, comma, 1/2. You know that's for 30 degrees, then you know 60's got to be the flip of that. You switch them. It helps, I promise. This works for a lot of people. For others, it's kind of like, just not seeing it or feeling it. It means you've got to come up with another way of getting those memorized, okay? But this can be very helpful. I still use this quite a bit because you just have a brain freeze and you can't think straight. So it's like, okay, what is it again? Yeah. Okay. All right, a lot to throw at you, I know, but I'm hoping that all of this was just, it was, the intention is to help you with thinking about making all of these connections, because you've got a whole bunch to memorize. If you've not made any flashcards yet, you better get busy. If you're not a flashcard person, then whatever you do to memorize, you've got to be memorizing this stuff, okay? So homework tonight, it's in 2 parts. There's 2 pages in the notes packet, and then there is a Delta map. So you're gonna want your plate for that Delta map.
Pages in our note packet.
It's pages 10 and 11. Okay? So we've kind of talked about this already, but it's good to refresh memory, and we've not done a whole lot with the radian measures. So I want you thinking radians. So you've got you had a visual in your other packet where we figured out what the reference angle was in quadrant 1 is just the angle, right? In quadrant 2, we do 180 minus whatever that angle is. So think about the fact that in radians, that means we're subtracting pi minus whatever that is. We need common denominator. In quadrant 3, we're going to do whatever the angle is minus pi, which is equivalent to 180. And then reference angle for quadrant 4, instead of 360 minus, we're going to do 2 pi minus, right? Okay. Do me a favor before I forget, and I don't know how far we're going to get with stuff. Cross this off. I thought I had deleted that, and I just realized that that did not get deleted when I was fixing this. So yeah, no, it's gonna have sines, cosines, and tangents, so. Okay, so reference angles, let's think. Let's think radians besides degrees. So negative 150 degrees is equivalent to negative 5 pi over 6. Just to try to reinforce and repetition of some of these values, I'm going to kind of try to do that quite a bit. So negative 150 degrees, I want you to think about where that's going to be. So negative 150 is about right there. So our reference angle is this angle here. What's that distance here from here up to 180? From there, what would that be?
-30.
Yep, it would be 30 degrees. So that is a 30-degree reference angle. If you want to think about this in terms of degrees, you need to go back to thinking coterminal angles. So negative 150, if we add 360 to this, we get that angle measure is equivalent to 210 degrees. And then if we do 210 minus 180, we get 30. Okay. Guys, think about kind of shortcut way of thinking about this. I'm seeing a something pi over 4 and another something pi over 4. What's the reference angle going to be? I'm sorry? And careful, the reference angle. So reference angles are between 0 and 90 degrees, or between 0 and pi over 2. What's the reference angle that has something to do with something pi over 4? That's going to be our reference angle. If you see something pi over 4, you know the reference angle is going to be pi over 4. So keep that in mind. All right, last one here, and then I just want to look at the examples down here at the bottom and see where we are time-wise. I want you to try to practice a little bit. 390 degrees, we need to think coterminal angles again. So subtract 360. So see, we don't get rid of all of those ideas that we did in the first unit. The trig is going to come back over and over and over again. So that's our reference angle too, right? It's just that 30 degrees. Okay, use your plate. Try finding these values down below real quick, and we'll go over those in just a minute. And last one, cosine of 7 pi over 4. Ashley? Root 2 over 2. Beautiful. Okay. I'm distracted today with all of this technology stuff that's going on, and I forgot to talk to you guys about the hand trick. So we're going to go back to page 4 for a minute, and let me explain how this works.